Damaged or deteriorated insulation in the secondary conductors can cause intermittent faulting. A large load placed on the circuit may exceed its capacity, causing the breaker to trip. Poor connections in the panel board or at the meter can create excessive resistance and generate heat, leading to breaker tripping. The breaker itself could be malfunctioning and tripping prematurely. The secondary feeders may be undersized or improperly installed, resulting in overheating and breaker tripping. Firstly, inspect connections. Thoroughly examine all connections in the panel board and at the meter. Look for any signs of corrosion, loose wires, or arcing. Secondly, check the breaker. Test the main breaker using a breaker analyzer or simply replace it with a new one of the same amperage. Thirdly, test conductors. Use a meter to test the insulation resistance of the secondary conductors. Any reading below 5 megohms indicates a potential insulation breakdown. Fourthly, monitor the load. Observe the loads in the circuit while tripping occurs. Identify any high current appliances or devices that may be overloading the circuit. Fifthly, check the cable size. Ensure that the secondary feeders are of sufficient size for the connected load. Refer to the National Electrical Code, or NEC, for appropriate conductor sizing. If insulation breakdown is confirmed, the affected conductors should be replaced immediately to prevent a potential electrical fire. If the load exceeds the capacity of the existing breaker and feeders, they should be upgraded to a larger size. Identify and eliminate any excessive loads that may be contributing to the tripping. When troubleshooting a frequently tripping main breaker, several factors need careful consideration. The problem is often intermittent, occurring only after several hours of operation and typically under high load conditions, such as when air conditioning, clothes dryer, and water heater are running simultaneously. This situation suggests a heat-related issue or a cumulative load problem. Start with the potential causes. One of the primary suspects is insulation breakdown within the secondary conductors. Over time, the insulation protecting these wires can degrade due to heat, age, or physical stress. When a large load is applied, the increased current flow causes the conductors to heat up, further stressing the weakened insulation. This can lead to a ground fault, where current leaks from the conductor to a grounded surface, causing the breaker to trip. Another potential cause is an overcurrent condition. Even if the insulation is intact, the combined load of multiple appliances might exceed the breaker's rated capacity. This is especially likely if new appliances have been added to the circuit or if existing appliances are drawing more current than usual due to malfunctions. Loose connections can also be a significant contributor. Poorly tightened connections at the panel board or the meter can create high resistance points. These points generate excessive heat as current flows through them, which can then cause the breaker to trip. The heat can also damage the breaker itself, leading to premature failure. Speaking of the breaker, it could be faulty. Breakers are designed to trip when they detect an overcurrent or a ground fault. However, they can sometimes malfunction and trip at lower current levels than they are rated for. This is often due to wear and tear, internal damage, or manufacturing defects. Finally, the secondary feeders themselves might be undersized for the connected load. If the wires are not thick enough to handle the current, they will overheat. This overheating can not only cause the breaker to trip, but also damage the insulation and create a fire hazard. To systematically diagnose the problem, start by inspecting all connections in the panel board and at the meter. Look for signs of corrosion, loose wires, or arcing. Corrosion can increase resistance and generate heat. Loose wires can cause intermittent connections and arcing, which can damage the wires and the breaker. Arcing is a visible spark that indicates a poor connection and can be a fire hazard. Use a screwdriver to tighten any loose connections, but be careful not to over-tighten them, as this can damage the terminals. Next, check the main breaker. One simple way to test it is to replace it with a new breaker of the same amperage rating. This will eliminate the possibility of a faulty breaker causing the problem. However, for a more thorough test, use a breaker analyzer. This device can simulate overcurrent and ground fault conditions to verify that the breaker is tripping at the correct levels. If the breaker passes the analyzer test, the problem likely lies elsewhere. To test the conductors, use a megger to measure the insulation resistance of the secondary conductors. A megger applies a high voltage DC current to the conductors and measures the resistance between the conductor and ground. Any reading below 5 megohms indicates a potential insulation breakdown. Lower readings indicate more severe insulation damage. This test should be performed with the power turned off and all loads disconnected. When monitoring the load, observe the current draw of the circuit while the tripping occurs. Use an ammeter to measure the current flowing through the main breaker. Pay particular attention to any high current appliances or devices that may be overloading the circuit. If the current exceeds the breaker's rated amperage, the problem is likely an overcurrent condition. In some cases, the problem may not be a single appliance drawing too much current, but rather the combined load of several appliances exceeding the breaker's capacity. If the load is close to the breaker's rating, even a small increase in current can cause it to trip. To determine if the secondary feeders are of sufficient size for the connected load, refer to the National Electrical Code, or NEC. The NEC provides tables that specify the minimum conductor size required for various amperage ratings. The appropriate conductor size depends on the amperage rating of the breaker, the type of insulation, and the installation method. If the conductors are undersized, they should be replaced with larger ones. If insulation breakdown is confirmed, replace the affected conductors immediately. Do not attempt to repair damaged insulation with tape or other temporary fixes. These fixes are not reliable and can create a fire hazard. When replacing conductors, use the same type and size of wire as the original. If you are unsure of the correct type and size, consult the NEC or a licensed electrician. If the load exceeds the capacity of the existing breaker and feeders, upgrade them to a larger size. This may involve replacing the breaker, the conductors, and possibly the panel board itself. Be sure to consult the NEC for the appropriate sizing requirements. If an overcurrent condition is identified, determine the cause and eliminate it. This may involve replacing an appliance that is drawing too much current, reducing the number of appliances on the circuit, or redistributing the load to other circuits. It is crucial to address the root cause of the overcurrent to prevent future tripping. Remember, electrical work can be dangerous. If you are not comfortable performing these troubleshooting steps, it is best to contact a licensed electrician. They have the knowledge, experience, and tools to safely and effectively diagnose and repair electrical problems. Ignoring electrical problems can lead to serious consequences, including electrical shock, fire, and property damage. Regular electrical inspections can help identify potential problems before they become serious. These inspections should be performed by a qualified electrician. During an inspection, the electrician will check the wiring, breakers, outlets, and other electrical components to ensure that they are in good condition and functioning properly. They will also look for any signs of damage, wear, or overheating. In conclusion, troubleshooting a frequently tripping main breaker requires a systematic approach. By carefully inspecting the connections, testing the breaker and conductors, monitoring the load, and checking the cable size, you can identify the cause of the problem and take appropriate corrective action. However, if you are unsure of how to proceed, it is always best to contact a licensed electrician. The information provided is for general guidance only and should not be considered a substitute for professional electrical advice.